Step off the pavement in any North American ravine, and you are immediately surrounded by a lush, damp ecosystem. The air smells of rich, decaying leaves, and a dense canopy shades the walking paths. But look closer. A silent, highly sophisticated chemical arms race is taking place right at the edge of the trail. This botanical illustration of northern water hemlock shows a unique, hollow root system separate by horizontal partitions. If you are foraging for wild edibles, mistaking a safe, solid root like a Jerusalem artichoke for this specific chambered root has immediate lethal consequences. When the most dangerous species in the woods look nearly identical to common garden vegetables, the ability to spot these minute physical differences becomes a vital survival skill. The most common defense mechanism we encounter belongs to poison ivy. It's an adaptable plant that can grow as a low carpet, a climbing vine covered in hairy aerial roots, or an erect shrub, almost always signaling its presence with its signature leaves of 3. Its primary weapon is urushiol oil. When this oil brushes against human skin, it seeps directly into our cells and triggers a severe localized immune response, resulting in the painful, blistering rash known as allergic dermatitis. Because urushiol is a non-volatile oil, it doesn't evaporate. It lingers on your dog's fur, your hiking boots, or your garden tools for months. If you burn the plant, the oil travels on the smoke particles, where it can be inhaled directly into your lungs. Yet, this intense toxicity only applies to humans and a few other primates. For local wildlife, poison ivy is a resource. Its white berries provide a crucial, calorie-dense winter food source for migrating birds and white-tailed deer. The plant is not malicious. Its painful oil is simply a highly localized deterrent, an evolutionary strategy to prevent grazing and protect its place in the local food web. Moving from the shaded trails to the sunlit edges of the ravine, we encounter a much more aggressive threat. These are the towering, invasive members of the carrot family, wild parsnip and giant hogweed. Looking at this photograph of expansive formal gardens, we can understand why Victorian horticulturists originally imported giant hogweed. In a highly controlled environment, its massive size made it an impressive ornamental centerpiece, but it quickly escaped cultivation. In the wild, giant hogweed reaches a staggering 15 to 20 feet in height, topped with massive umbrella-shaped clusters of white flowers spanning 2.5 feet across, and its size is matched by its chemical payload. The plant's clear sap is loaded with toxic compounds called furanocoumarins. When these compounds contact skin, they cause phytophotodermatitis, stripping away the cell's natural UV protection. The sap itself doesn't cause the burn, but subsequent sunlight cooks the compromised tissue, resulting in severe blistering and scars. Identifying these giants from a safe distance is critical. Look for incredibly thick, hollow stems, marked by dark purple blotches and surrounded by coarse, stiff bristles. By weaponizing the sun against the human body, these invasive giants turn a brightly lit clearing into a major public health hazard. Down in the lowest, wettest parts of the ravine, hiding in the muddy creek beds, we find a plant that requires no sunlight to do its damage: spotted water hemlock. This is officially the most violently toxic plant native to North America. Water hemlock contains cicutoxin. Unlike the localized skin irritants of poison ivy or hogweed, cicutoxin is systemic. If even a walnut-sized piece of the root is ingested, the toxin directly attacks the central nervous system, causing rapid convulsions, seizures, and frequently death within hours. This reference chart of the parsley family shows why fatalities occur. To the untrained eye, the delicate fern-like leaves and white umbel flowers of deadly hemlocks look almost identical to the edible wild carrots, parsnips, and ramps foragers hunt for in early spring. Water hemlock's systemic toxicity represents an unforgiving ecological boundary. You cannot rely on trial and error here. Foraging requires a zero margin of error identification. These ravines function as critical paths for local wildlife, even as they harbor some of the most sophisticated botanical defenses in the natural world. Navigating this space safely comes down to recognizing a few distinct visual cues: the jagged leaves of 3, the hollow purple blotched stems, and the broad umbrella-shaped flower clusters. Attempting to scorch or eradicate native toxic plants disrupts the balance of the ecosystem. These species evolved to fill specific ecological niches, feeding wintering birds and deterring overgrazing. Understanding how these botanical defenses actually work allows us to shift our perspective away from fear and toward informed caution. Recognizing the chemical limits set by these plants is the foundation of true ecological literacy. It is the exact knowledge we need to step in